Right, so yeah, it's me again, sorry. You'll have to do with me for the next 20 minutes. But the good news is I see a lot of people behind the laptop, right? That's how it goes in meetings like this. At some point people start doing their own stuff. Great, I want you to be behind your laptop. I'm only going to talk for maybe 40% of the time, and the remainder I would like to see if we can try to get you to run the Easy Test Suite on your own system. Let's get started. The goal of the Easy Test Suite is that we want to test the functionality and the performance of software stack. And we want to do this on multiple systems because, well, the Easy software stack should be available and working on any system in the world, right? So we need to also be able to test a wide variety of systems. The challenge that poses is that every system is different, so we need a test suite that is portable. And that is not very common in the HPC environment. A lot of the test suites are developed very specifically for the system of a site themselves, right? So, for example, the Easy Test Suite is based on Reframe, but if you look at the typical Reframe test that people write, Reframe expects you to define keywords like number of CPUs per task, number of tasks, number of GPUs per nodes that a particular test should use. And this, of course, matches up typically with what you have in terms of a system, right? If you have a pure MPI code, you would say, okay, the number of tasks equals, I don't know, the core count of a node, or 2 times the core count of a node if you want to run across 2 nodes. But that means you have hard-coded system-specific information in your test class, meaning it's not portable. So, yeah, Reframe offers amazing fine-grained control. That's great, but it comes at the cost of portability. But there is something we can do, and we did it. So basically, we said our philosophy is going to be that everything that's system-specific has to be in the Reframe configuration file. That's the only thing where we want an end user to describe their system, and then the test class should do something sensible based on what it finds in the config file. What is something sensible? What does that mean? So for example, for a pure MPI code, we would declare in the task class, okay, just launch 1 task per core that you see in the Reframe file. So if the Reframe configuration file says this partition has 128 cores per node, fine, you launch 128. It also means we should skip tests if the test says, okay, I need a certain amount of memory, and if it sees that the config file states the system doesn't have enough memory, just skip it. Mind you, I put a note here, tests are not the same thing as benchmark. So this type of generic behavior is not necessarily going to give you the best performance of a certain code on your system, right? You have a hybrid code, you might want to play with the balance between the number of threads and the number of tasks on a node, etc. The test suite doesn't do that, right? It just makes some assumptions, runs it, and that's fine, because the only thing we really care about is if we see changes in performance, right? We want to know about performance regressions. We want to make sure that we don't introduce anything silly in the repository that kills the performance. What does a test class look like? So this is the most simple one that we have. It's also the tutorial, if you look at the documentation on how to write tests for the Easy Test Suite. The key part, well, I see that not there, but the key part is actually at the top. It inherits from a class called EasyMixin that contains all of this logic that does things like, okay, I want to launch 1 task per core. This test class then just declares what it needs, right? So this says I need a CPU to run. I want to launch 1 task per core. I want to run this test for every module that's named MPI for pi / something, right? So if you find multiple modules, I want to create multiple test instances. Then there's a bunch of standard Reframe code. This is just so that we can automatically tag the test. So, if this test matches the bench name CI, it will actually get a tag called CI. That helps you in filtering tests at runtime. And finally, the test declares how much memory do I need. So this is a function typically of the number of tasks, or actually the number of tasks per node, because we declare how much memory do we need per node. And now I want to get almost onto the hands-on. It's going to be like 5 steps. First, we need to install the Reframe test suite and install Reframe and the Easy Test Suite. Then we need to create a Reframe configuration file. That's going to be the most time-consuming part. And then basically we'll just try to run it. First, listing all the tests, and then just pick one of them. I would suggest the OSU one on 2 cores. You can select tests by passing it a test hash. You will see in the list it ends with a test hash. If you just pass the -n command and then the hash, it will only try to do a dry run or a run for that test. The presentation is online, so there's some commands in here that you can just copy paste to make things faster if you want. It's in my GitHub. My GitHub handle is Caspar VL. and then there's a repository EUM'25. We also have official documentation, of course, on how to write these configuration files. It's much more extensive than my slide, so if you want that for reference, it's there. First step that I'll actually not go through, but it's just installing the virtual environment, and there's 2 commands to check that it can actually import the stuff. What I do want to show you a little bit is the second step, which is a little bit more involved. We have a template reframe configuration file. That's the settings example thing. You can download it. Then here we export a couple of environment variables that also do reframe configuration, basically in order. It tells reframe where to find the config file, the prefix where it's going to put all of the staging in the output, the search path, so that's where it has to find all of the tests, and then we tell it to search the search path recursively. So if you just run this, then you have that part set up, and then we start to modify the actual config file itself. There's a couple of slides on that. I'll not go through them, but I will show you what the config file looks like and what you typically need to change. Let me works. Download the config file. Nothing. Why don't I get anything? So, yeah, like I went out of presenter mode and then it's gone. And I have a second screen. Try with this one in between. I don't know if it will help. Anything, huh? Yeah, I can show it from there as well. But okay, maybe let's see if that works. If your laptop works, I'll just show it from the website. I think it's not the laptop. All right, in the meantime, download the slides and get the virtual environment setup going. It takes 1 minute, I guess, but at least it will save us some time after. Try again with mine. It does. Second display, wait a second. Oop. There we are. All right, so the config file. Basically, you know, name, description, it doesn't really matter, so we'll just leave it. The module system, if you're not running lmod, you'll need to change it. Host names, forget about it for now, we'll just match anything. The staging there, that needs to be a directory that is available throughout your cluster, right? So it needs to be a shared file system. And then you define sort of the virtual partitions that you have. I would suggest just to define one and take a CPU partition. That's the easiest if you have it. Again, name and description doesn't matter, but you need to state what kind of scheduler do you have. We have Slurm. What kind of launcher do you have? You can use MPI run or srun or whatever you want. The access flag basically defines the virtual partition. So this is, in our case, like we would have a -p roam here to get access to our roam partition. Things like number of tasks, the time limits, etc. Those are injected based on the test class themselves, right? So this is just how do you get access to that partition. So if you have a, let's say, a mixed partition, you might need to set additional constraints to get something that's homogeneous. And then in the resources dictionary, basically here you need to define for my scheduler, how do I define the amount of memory per node that I require? So for Slurm, that's a dash dash mem equals something argument. The something needs to be sized because that's actually what the test suite expects, and it will inject whatever it needs in terms of memory. Then in the extras, that's where you declare how much memory you have available per node for this partition. If you have Slurm, you can actually you can query Slurm, but if you make an estimate, round it down to make sure that it doesn't exceed it, it's fine. Then the features, that basically tells our tests like what do you have available here. So by declaring features.cpu, you tell it, okay, I want to run all of the tests that say that they need a CPU, I want to run them here. On the GPU node, you might not want to do that, right? On a GPU node, you might say, I just want to run GPU tests on the GPU node, and I don't want to do any CPU tests. But you could declare both. Then there's this list that we create from the skills. Skills are sort of the standard skills that we create our test set. It varies from a single core to 16 full nodes. If you say, look, my cluster is very, very small, you can say, I'm just going to do all the skills up until 2 nodes or something like that. For now, it doesn't really matter. We're just going to select an individual test anyway. And those are basically all of the changes that you would need to make. I would just comment out the GPU partition if I were you, and then you should be able to run it. Let's see. With that, let's get started. There are 2 other people in the room who know what to do, Sam and Lara. So if you need help, wave your hand, call any of us, and let them know. Yeah, I'll put that back up. So this is the link. Go to my GitHub, Caspar VL, and then EUM'25. There's eternal glory for the first one to get it running. If there are questions online, don't hesitate to ask. We'll try our best to answer in the chat. Yeah, you can use the reframe module in Easy. That should work for Yeah, it's a slightly older one, so I think it should work for everything except the metal walls test. Oh yeah, good point by Bart. If you do copy paste, mind you, there's a Python version in here, so you might need to adapt that to your own system Python version. Did anyone already managed to do the dry run?
So I'm going to stop the stream here so we get set up for the next speaker. We're running a few minutes behind, but not too far. So we're going to get started there in like 2 minutes.